Hi everyone. Am I audible? Good morning. How are you all? Since I think we have got a gap of 1 week, right? 1 week or more than that, 1 or 2 weeks. So how it went? How it is going? You guys got the time to do the revision? No, Raju. Class didn't happen on Tuesday and all. We'll always have class at the same time now onwards. There were a lot of changes in my life, and you guys have to suffer because of that. I shifted. I so many things happened, right? So yeah, now we'll continue at the same time every weekend. So I will not bother anymore. And yes, everything is well. Great. Thanks, Ravi. So let me just. Hmm. It's a good one, Shamil. This place is good. So can anyone tell me quickly what we did last time? For that, Ravi, you will have to come here, right? Sure, Atul, I will do that. Can anyone tell me where we were in Python? Which part? Okay, arguments. Okay, yeah, thanks. Let me just open the files. Give me a minute. Okay, Shyamil. I am sharing my screen. So, firstly, I will give a brief idea on what we have covered so far. So, we started with, like I'm telling you from the starting of the course, what we have done. So, we started with the introduction to data science, business analytics, those things we did, like 1 or 2 session we spent on that theory part. After that, we started with Excel. So, we did Excel related functions and everything, and then we went on statistical part. In the statistical, 1 or 2 topics I left for to, like, I will make you practice everything from statistics in Python as well. So now we started with Python. In Python we have covered the introduction to Python, applications, why we need it, then the data types in Python, what are the operators we have. So we practiced all the operators, different data types. And after finishing the data types, we started with functions, in which I taught you about lambda function. Then the next one was user defined function. In user defined function, you have to take care of few things, like you can pass arguments, different arguments. There can be different way to write it. So those things I hope we were discussing last time. So you can start with that. And also we talked about loops, different for loop, while loop. Those things we did already. So yes, any doubt from the previous questions? Sorry, from previous topics, if you have, you can ask me. What, Shaman? What your star pattern? I don't know what you're writing. So let's go here. Means lambda function user defined. Which one, Shamal? What is star pattern? Pattern. You wanted to write star pattern or what? Oh, question. For a question related to assignment, please ask your doubt painter. Okay. I hope she can help you out. In case if not, then we'll see. So let's see here. Function arguments. So we were done with this or not? Can anyone tell me? Function arguments were done? That I don't know, Shamal. Just confirm from them. I don't think so. No one talks on call. Sorry. K, okay. Okay, here. Wait, let me check. Here's the default keyword arguments. Can anyone tell me the full form for this? KWARG. KWARG, full form. Keyword arguments. Great. That means you guys practiced it. Okay. Today I need to practice on Google Colab. Let me open the files in Google Colab. Just wait for 2 minutes. Yeah, Shamal. So we have been doing it's top enters. Why it is. Okay, finally. Lambda shortage, waiter, global. Yeah, we talked about this, no? Global, local. So in KW args, right? Here you can pass both keywords and arguments. That's what we were saying last time. And whenever I'm saying keywords, so you can relate with dictionary. There you have seen that the values were stored in this format. You have a key and then a value for it, right? And so on. You can add as many key and the values as you want. So when we say that you can, let's say you can define a function using this double star chaos, that means double star indicates that you can have as many keys and values as you want. For example, when I said here describe a person, there is not any limit on the keys and values. See, I have defined four of them here. First is name, age, profession, and location. So double star, one you can remember for key, other you can remember for the word for it, means value. So keys and values you can define. But if it was only single star and arcs, then we were passing only the arguments, not this key values. Only some values were passing there, right? Like we did previously. So this is the difference between star arcs and double star KW arcs. Never forget this difference. It is very important. And from initially, they might ask you. I'm not sure how it's going now, but initially they used to ask these questions. So yes, that is one thing. Now when I'm defining this function, right? So I'm saying define DEF. That means I'm writing a user defined function, and this is the name of that function. Describe person. And let me zoom it a bit. So describe function is the name of that function. Describe person. Here, when you pass double star chaos, that means okay, you can pass as many arguments you want. You don't need to specify anything here. Later on, you can call with whatever you want. But since we are going to have both keys and values, so now we can fetch them from here and we can print them. Okay, it happened. It was possible because I wrote here double star chaos. If I wrote the star argument and then I'm trying to run this, it will not run. It will show me error. So because it is already here in the dictionary format, I can access keys and values from the items from here. So dot items, if you remember, this was a method in your dictionary. So that's why I'm writing for key and value in this kiosk dot items, print f key and value. So in this format, your output should be printed. So I hope you guys remember what is the use of this f here. Yes, Shamal. So this is a general function, right? Here you don't need to write. When you will call this function, right? Then you can define. These are nothing but keys and values. See, age is a key, 28 is the value for it, and so on. So what I was asking, what is the use of this f here? Can we do without writing f? Then what will happen? If I'm not writing f, then how the output will look like? Formatting. Correct, Shalish. Used to print variable inside a string. Correct, yeah. Very good. No memory has to be allocated and then print. Okay, Shamal. Someone wrote some question. Key value are variables and only items is a defined function. Yeah, Praveen, basically this is a variable and this is the value for it, right? But since this key and value pair is available in dictionary and we call them together an item. So that's why we are, in order to print them, we are calling with this method items. Yes, you are correct, Shamal. Fine. So see, I want this to be dynamic. Dynamic in the sense that whatever key and value I am passing, that should be printed here, correct? That should be printed. We don't know what it could be. It could be anything, whatever you will pass here. So in order to make it dynamic, we have to use formatting. So if I'll write F here, this will make sure, and this square bracket indicates that these value needs to be formatted. So if I write F and put them in square bracket, now whenever a new key will come, it will show here. See, now it is age. In second loop, it is coming age. So I initiated a loop. In first loop, first key value will be printed. In second loop, second key value is printed. Third loop, third one. And fourth loop, fourth one. Okay, Prakash, returns all key value pairs item. Yeah. Yes, in the line for key value in items are the three names. Key value counts are variables and only items is defined function. I don't know. You're getting confused a little, Praveen. Let me come again for you. So whenever we are writing this, right? This is the way. See, keyword argument basically. It is asking you that here you can enter keywords and values. First of all, that is the thing. This is just an argument. It is not a variable. This is an argument you are passing. First thing. Second thing, this argument can have keys and value both because we are writing kwargs. And there is no limitation that how many you can enter. That's why we wrote double star. Since you have both key and arguments, the data type will be dictionary. So data type is a dictionary here. And this dictionary is having name as key, value as strings, then age as key, value as 28. And they are nothing but arguments. They are acting as an argument for this function. In previous class, I have talked about arguments as well initially. No, you don't need any input, Shamal. See, this is a general function we defined, correct? We kept this function. We defined it when we kept it somewhere. Whenever needed, we can use it. Whenever needed, I will just call it. And let's say I need to call someone, I need to know their age, whatever data I need to insert, I can write here and it will show me in that format. So that's why it is making our work easier. Double star A for X and Y in A dot items. No, it should be kwargs. You cannot write A here, Praveen. This is the keyword you have to write. This is fixed inbuilt name you have to give. Otherwise, it will not come. This function we can do only on Google Colab. Yeah, you can do in Jupyter as well. I am doing on Google Colab because this is my new laptop and I need to do those setup for Jupyter. It is not done yet here. Yeah, you can call anywhere in this program. After this, you can call it anywhere. Below, not above it. If you'll do above it, it will not come. So below you have to do anywhere. Praveen, are you good now? Yeah. So Mohan, your key, this is the, see, this is having a dictionary data type. So whatever methods you can apply on a dictionary, you can use here as well for these keyword arguments. Okay. Yeah, you can put here X and Y. That will work, Praveen. Here, since this is a general temporary name of the variable, you can write X and Y and you can print X and Y. Okay. Now we have default arguments. So these are important ones because whenever you will define a function, you have to take care that how you are calling it. So let's say I'm defining a function add, and in that one I have three variables a, b, and c. For b and c, we have kept the values as a defined one, like b should be 5 and c should be 10. That means these are the default values we have already. These values are by default, they should be 5 and this should be 10. Whenever I will call return a plus b plus c, only one value is mandatory we need to pass because b and c is already defined. If I am passing only one value, so it will show me 3 plus 5 plus 10. So output for this one will become how much? 18, right? Then, yeah. Then if I'm writing add 3 comma 4. Now first one is fixed for the value a. If you're passing 4, then that will be replacing this 5. See, by default, B value is 5. But if you'll pass something new, it will get updated with the new value. So now B is having value 4. Since you are not passing for C, C will still be 10 only. So what is the output now? Yes, very good. So that is 17. In the third case, you can see I have passed all the three values. It will simply be 2, 3, 4. This is, yes, yes. Yes, Praveen, correct. So here we have 2, 3 and 4. 4, 3, 7 to 9. This is how it will work. Default arguments, we already have by default. We can pass it. Then we can have the value. Okay, Piyush, it should be in an order like A, B and C. You can pass any value for A and C. By default, C is 10. If you want to change, like we did here, you can do. A you need to give. That is a mandatory one because the value for A is not defined here. So this is known as default argument where you can already have the by default values. And when you are calling it, these are the different ways you can call it. At least one is mandatory. Let's see another one. Keyword augments. Keyword in the sense, here we were calling them by directly, right? 2, 3, 4. You can also call with their key values, this key and words. That means you don't need an order now. Here you have to give it when it's like, let's say you're passing 2, 3, 4. So by default, the things were like first value will go for A, right? Second value will go for B. Third value will go for C. But if you want to change this order, you can call them with their name itself, something like this. Let's say again this function is same which I defined above. It is same one only. But when I'm trying to call it, I'm calling with both key and words. So I'm saying that add b equals to 10, c is 15, a is 20. Now if you see this order is not in the same way. Here we have a, b and c, but I'm calling b, c and a. So if you'll write with their key and then values, then it's fine. It will give you the output. So in this case, the output will be 15 plus 10 plus 20. Then how much it is? 15, 35, 45, right? Then if you'll give A equals to 10, B and C is already given to you. So it will come 25. I hope you got the difference. See here the difference was you're not writing A, B and C anything. You're just passing some numbers and based on their position, it was returning with output. But in case if you want to write with their name itself that okay, I want to put the value for here. So we are putting it like that. No over no overridden. By default, it is already there, Piyush. Whenever you will call it, then this is just an instance that you want to see the value like this. Nothing will change in this function. Function will have a values as it is. It is just that you are creating an instance. Yeah. Now what about positional argument? So it is just similar to this one. Positional argument in the sense based on the position itself, the values will get added. So here I am saying a plus b minus 6. So based on the position, a value will have 50, b will have 30, c will have 20. What is the output for this then? Tell me guys. These are easy ones to understand. Okay. See, most of you are doing the mistake. Yeah, correct. Hemant, correct. Anita Prakash, you guys are thinking that it is same as this function, but it is not. See, it is minus c. A plus b minus c. No, Krati, we don't have. It's just today itself. The class is today and it will continue on this. So it doesn't work for functional, or do I need to use Google Colab? Why, Tushar? It should work. It should work, Tushar. Okay, so let's run this. We got the output as 60. You're not getting any output? Can you write print? Are you writing in the same manner? Just try this code, Tushar. I'm pasting it there. Try this code and let me know. I'm pasting it in chat. Yeah, I pasted it. Just try this. Then we have default. Now there are some certain rules which you need to follow. If you will not follow them, you will get some error. So we have 3 to 4 rules. These are easy to learn as well. So let's see. First one is saying default argument should follow non-default arguments. Okay, Tushar, I wish I can see your screen, but still no output and no error. Why it is? Can you restart your kernel once? Sometimes it happens because of that. Here on the top, you can find some kernel option there. Like here we have restart session. In Jupyter, we have restart kernel. Do that and let me know. So first one is saying default argument should follow non-default arguments. So what I wanted to say, should follow, right? That means firstly you need to write non-default arguments. Then you should give default. It should be like this. Default argument should follow non-default. Means firstly there should be non-default arguments. Then you should have default arguments. Default argument, I hope you got the idea. Default means the value which you already have defined, a fixed value you have given. So that one is default. So if you are writing a function and you want to give a default value, make sure it comes after the non-default. Because let's say I'm not doing that. Let's say here what I did reverse. What I did here in this example, I'm saying that A should be at here. A should be here and then BC should be here. A is having a default value. I kept it at the first place. And then I'm adding them together and here I'm calling as well by passing the value that A is 4. Do you guys think we will get an output here for this block? Is it following the rule or not? Correct. It is not following the rule. So if I will run this, I will get syntax error. See. And the same thing which I wrote here, the same error will be reflected. Yes. Non-default is positional. Correct. So if non-default is positional, you have to pass the value positional. See, here it can be, no, here it is, this is default. And if you want to pass in the positional, as a positional argument, you can pass it like this. It is not like that it is positional or something. You cannot categorize it there, Praveen. While calling itself, you can call it in that manner. Either you can make it positional or you can make it something like this keyword. So if we'll call it with the position, so whatever you'll give after A, it will come for B and C. So what is the corrected code then? See this code, it will run now. Because this default argument has been kept after the non-default ones. This will work. Now 7 and 8 if I am passing, B will get value 7, C will get value 8. So this will return as 20. Any question so far? Okay, I will repeat it. So I was saying that whenever you're defining a function and you want to have default arguments in your function itself, you want to have default argument, make sure it appears after the non-default. If you will keep it before non-default, something like this, then you will get the error because this is a rule we need to follow. This is nothing but a rule in Python. So we need to follow it. This non-default should always come after the, sorry, default should always come after the non-default. So that's what it is, nothing more. Okay. Then we have second rule that is saying keyword argument should follow positional arguments. That means now this is about when you're calling it. Okay. When you're trying to call it, then what you have to make sure that keyword argument should follow positional arguments. So after positional only, you should be able to keep the keyword arguments. So if I'm running this, I got 17 because it is perfectly fine. But what could be the error? Let me show you the error code as well. Just add one block. How should I write it so that it should give me error? If I'll put c equals to 10 initially, so we got this error. Why we got this error? Because it is saying positional argument follows keyword argument. That means your positional argument should always be after keywords. Okay. And here if you see, this is what we are following. Right. So here, firstly, you need to give the position for A and B, and then you can write your keyword document. But what we did here, we did ulta, reverse. We have firstly give the keyword and then we are giving the position. This is based on the keyword, right? And after that, if I'll give the value 3 and 4, since I already have written c equals to 10, they will not be able to understand what this 3 and 4 is for. Because it could be A and B, so there is a confusion. That's why we got this error. But if you are writing it like this c equals to 10, that means the rest of the value should be for 3 and 4. That is for A and B. Respectively, it will take it. Any questions? Yes, Sandeep. In the same way, if you are writing C, B, and A, again you have to follow accordingly. Let me show you in case if you want to check it. So you are asking me to write here C. Yes, set the default at the end. Yes, Anita. You are asking me to define C, B, and A. So if I'm going to run this, I think one more rule is there. Here we got error. So why we got the error here? See, yeah, one more rule is there. That is just after this, Sandeep. So in order to run this, the thing is that you're saying c equals to 10, but this one is following positional argument, right? So it already have the value c as 3. But if you're passing it again, then that will return you the error because it will get multiple values for c. So for this part, you need to be sure that when you're calling, make sure that A is the default one here, not C. In the same order like we did here, C equals to 10. If A is at the last, then make A equals to 10. Now it will run. Correct? Positional first and default argument after that. Yes, Praveen. So yes, the rule says that initially also we have seen here. See, this is the order and yeah, good observation, Praveen. Okay, guys. So let me just. What happened? Prius, you didn't got it. Here we are just saying that if you are writing A, B, and C, make sure the default one is at the last. So if C equals to 10, if you want to call this with keywords, C equals to 10, you have to write it at the last. And this variable should also be like C. You cannot change it. Let's say if I'm writing A here and I want to pass it as a default, I have to write it at the last. Then respectively C and B values will be taken and for A it will be 10. This is what the rule is saying. Now, next one, there is a question, create a function to find common items from to list. That is a, no, no, that is just a, what to say. Okay, let me ask this question to everyone. Shyamal, this is a, if everyone is confused, I need to know. What is this DEF? Is it a library, guys? Or what? If not library, then what? Then what? Yes, Sanita, correct. So initially I've told you that there are some reserved keywords in Python, right? So this is again the reserved one that is having some own meaning, right? So it is a keyword to define a function, not a function. This is not a function, guys. This is just a keyword. Just like you are using what to other things like print you are using, correct? Print is a function, by the way. It is updated with a function. This is DEF, just a keyword to define a function. This is a keyword in Python. Yeah, print input are functions. Great, guys. Okay, good, very good. Now, in order to find common items from list 1 and list 2, you can use set. You can convert them into set and take their intersection. So, this is one example. You should try by yourself. This was for you as well. So, I will leave it on you. There are different way to do it, and I already have shown here that what are the different ways to do it. You can practice on your own. And if you don't understand any of them, you can ask me in the next session itself. Okay. This is the corrected code which we did earlier as well. So this is fine. Now next rule is saying all keyword arguments passed must match one of the arguments accepted by the function and their order is not important. So how many of you understood it? Just read the line again. All keyword arguments means if you have keyword arguments like A equals to 5, B equals to C like that, must match one of the arguments accepted by the function and their order is not important. So if you are calling A, B and C with their key and words, then their order is not important. You can write B equals to 5, C equals to 3 and A equals to 9. This will work because you are already passing the value and key both. So order is not important in which you are passing. But if you will change their name, right? Let's say this is B and I'm writing B1 here. So function will not be able to recognize B1. Then you will get some error. Just like I did here. Here I wrote A, B and C. But when I'm calling it, instead of B, I'm writing B1. That B1 is 5. So in that case, I will get error. The simple rule, I hope you got it. See, order is not important in the sense, if it is A, B and C, I can write C here. I can write A at the last. That will be not an issue. But what matters is the name of it. It should match exactly. If B is written as B1, I will get error. See. So this argument is not there B1 and we got error. So what is the corrected code then? Then in that case, you just need to pass the exact name what you have given here. So if it is ABC, call them by A, B and C. In any order is fine. So this will work. Any question on this one? Okay, now one more thing. I think this is fine. No argument should receive a value more than once. This is not a star case. In star you can do, but if you are passing it like this, some keys and values, you are not supposed to give more than one value here. So A equals to 10, B equals to 5 and B equals to 10. Again I am writing, I am defining B 2 times here. This will return me an error. If you are repeating any keyword argument, this will throw me error. Okay. So this is something you should know. So what is the corrected code? Just pass only one time. That's all. And we already have seen this rule. Default arguments are optional. Initially only the first example which we did, in that we have seen that these are optional, correct? If you already have passed default arguments, You don't need to call it again. These are optional now. Either you can call or you cannot call. Correct? So if I am running this, I got 70. I don't need to call for B and C because they are optional now. They already have some value. That's all about arguments and these small things. These are very important. That's why I added them. If you remember them, it will help you. Let's get back to PPT. Whatever rules we practice there, it is here. Points to remember. Next, we have some modules in Python. Not all, we are not going to discuss everything here. The selected one, which we'll be using very frequently, we'll talk about that. So, what is the module very thing? The very first question, what is module? See, just like in our homes, right? We have a particular place to do the thing. Let's say we cook food in kitchen. We sleep in bedroom. We cannot do the vice versa, that cooking in bedroom and sleeping in kitchen, correct? So in the same way, in Python itself, in order to perform a particular task, we have a module. Let's say if I want to do mathematical task, so there is a module with name math, which where you can find all the functions related to mathematics. Let's say now you want to do something, you want to generate numbers and all, then you have random module. Random module will help you to generate the numbers randomly. So just like that, to do a particular task, those are defined with a module name where you can go and pick the function and get your job done. So this is what a module. So if you see logical organization of Python code, just like we have organized the things in our home, book should go in the shelf, right? I should be sleeping on the bed. So there is an organized way to do the things. In the same way, for understanding the code, for picking the functions, we have defined different modules based on their role itself. Let's say I have talked about libraries as well, right? So we have libraries, inside that we have modules. In that modules, we have functions. So this is the hierarchy. So let's say I'm talking about pandas library. In that pandas library, I can have some module that will do manipulation. So that, let's say that is manipulation something. Inside that I can find a lot of functions that will help us to make our job done. So this is the hierarchy we are following. Modules will have functions. Libraries will have modules. So related code are grouped into a module, which makes the code easier to understand and use. Just the same thing which I said. Any Python module is an object with different attributes which can be bind and reference. Since this is an object, so we have a concept of object in Python. It's object-oriented programming, it is, right. That means a module can have different attributes. Whenever needed, we can call them and we can use them. So that's what we have for the modules. And let's see some examples as well. So first is the math module. So I told you that all the mathematical functions you can find here in math module. Now let's say you want to take a square root of a number. You don't need to go and write the things like we have seen one operator, right? Double star and all. So you don't need to write double star 0.5. It will take you power of 0.5. This is a way to do it. You cannot, like, we already have a function in math module. We can just use it. We don't need to do this because this is not looking a very standard way. So that's why this math module will help you in doing all these operations. So if you want to take a square root of a number, you can go and ask math dot square root. From math module, you are using sqrt function and then you can pass a number for which you want to take the square. So this output will give you 2, right? And then, like, but for that, you need to import math firstly. You cannot do this directly. Firstly, import math and then use it because this is a module. Now, next thing what we have. So here are the different example for math square root. Yes, we can get a list of these modules. There are a lot of them, Shamal. So I am only telling you which you'll be using in data science, like math and random. This is also in your syllabus as well. These two are very important, which we'll talk. So here, let's say if you want to get a square root of 3, you will get the output something like this. If you're asking for 100, you will get output as 10. So basically output will come in float. right? Then if you guys remember, I talked about seal and floor, right? Initially. How many of you remember what is seal and what is floor? Good, Praveen. Wow, Shamal, you also remember? Biryani. You gave me biryani examples, right? Seal top. Yes, correct, Google. Seal will return you the highest integer. Floor will return you the lowest integer. Okay, Neha, great. Yes, Anita. Now let's say this example. I am saying math.seal. So from the math module itself, you can use this seal and floor. So you can write math.seal 4.5867. Since you are using seal, it will always round it off to highest integer. So 4.5, the nearest highest integer is 5. So output will be 5. And if you are using floor, even if you are writing correct, Praveen, even if you are writing 4.99 and applying floor on it, output will be the lowest integer. Means what is the lowest integer around this number? That is 4. Output will become 4. Okay, great guys. You all remember it. So let's see the next one. So we have also one more thing, POW. POW stands for power. Power in the sense here, not that power. This power means, let's say I'm writing 2 to the power 3. If you want to write something like this, you can pass the number and power. 2 indicates that the number, 4 indicates the power. So the output will be 16. 2 to the power 4, it is 16. Then we have FABS. FABS means absolute number. So if you want to return the absolute number, you can use FABS. FABS. This is a function for absolute. So math.FABS minus 5.5. The output will become plus 5. Okay. It will always return you a positive value. This absolute function. Absolute value in the sense, have you seen something like this in math, Hemant? This mod of minus 5.7. So it will return you 5.7. This is nothing but absolute. We call this sign as absolute. If you means basically converting a negative number to positive. Whatever you will enter inside an absolute value, it will always return you a positive number. Even if it is negative, you will get it as a positive. Absolute, you can understand, you are only considering magnitude and not the values, like whether it is negative or positive, you don't care, only magnitude. In the same way, let's say you want to calculate sine, cos, tan, means different trigonometric value, then again you can use using math.sine, math.cos, and so on. So these functions are available in math module. I hope you all got an idea. So let's see the next. And we don't need to practice anything yet. These are just basic things. And here you can find more of the functions. If you want, you can explore more. Like few things have been here. See degrees, radians. So I think we talked about them, right? Seal, square root, exponents. Exponent is also there. So if you write exponent, that means you are taking e to the power 2. If I write 4 here, that means e to the power 4. Like that. And वहाँ point क्यों show हो रहा है? Where is point? Which one? Rudrani? Math.pow. Oh, previous slide. Let me get back. It will always give output in float. That's what I mentioned as well. These functions mostly will give you the output in float format. Okay, great. Now fabs we saw, floor we saw, log. If you want to take log, you can use math.log. Give the number and the base as well. Because in log we have base as well, right? Sometimes we get the base 2, base 4, you can pass here at the second position. Then we have log 10. So log base 10 is also there. Math.log base 10 and pass the number. Yes, we can use sine cos theta as well. Just like we saw the last example. Here you saw math.sine and then 270. So in the same way, you can write math.cos, math.tan. Here you can see math.sin, math.cos, math.tan, math.degrees. If you want to convert some angle into degree, you can write degrees. If you want to convert some angle into radians, you can write math.radians. And that's why some examples are also given here. So simple. And next we have random module. Some random functions we already have seen actually. If any of you remember, radians, uh, galat spelling. Shyamal, that is wrong spelling. This is radians, not that radians is different what you wrote. Ha. This is the way to represent an angle. If you guys have seen mathematics, you guys have studied, so then there you must have seen. How, can anyone tell me how much degree is there in radians? 1 radian? Anyone? 180. Okay. I'm getting answers. Piyush saying 360. Bhupinder saying 180. Praveen is saying 57. So I will write one relation here. Degree is equal to radians into 180 divided by pi. Now this is a formula. If you want to get the value vice versa, let's say you want to check how many degrees are there in the radian, you have to multiply with pi and divide by 180. Okay, so you guys have calculated? Okay, then I can understand. Okay. Correct. Shamal, you understood it now? We are going a lot in mathematics. You guys don't need to know this much, but yeah, I wrote the relation. Angles we have right in daylight 270 degree or something. Sometimes we want to change this unit. We want to see in radian. So this is the way to do the conversion. Great. Let's see the next part. So next we have random module. Previously I have used some random functions like rand int or random.random. How they will work, let's see. Whenever you are writing random, that means we can generate some random numbers. Prashant, you are raising your hands. Do you have any questions? Let's see. So the random module provides access to functions that support many operations. We can apply random module to functions as well. Like we can use it for many operations, and how we'll see. Perhaps the most important thing is that it allows us to generate random numbers. So as I said, whenever random module comes, this is the very important thing that we can generate some random numbers. Sometimes we are not able to write the numbers or the data on our own because it is a heavy task to fill the data. So what we do for our practice, we can randomly generate the data. So in order to do that, we can take help of this random module. Now how to generate the numbers? Let's see the different way to do it. This one is saying random dot. So firstly, you need to import random random module, import random. And after that, start writing random dot rand int. Means you are generating integer random numbers. And it will accept two parameters here. If I will write 0, 5, that means it will return me randomly generated integer from 0 to 5. It could be any one. The output could be any one number. What I did here, see, I wrote random.rand int 0, 5. That means I am saying that return me a random number from 0 to 5. It could be 5, it could be 0, it could be 1, it could be 2, it could be anything. Whatever the system generates randomly, that thing will come. You guys can try this. And what if I am writing random.rand? Okay, let me show you one example. And let me see if we already have the file on it or not. Give me a second. It will generate only one. But in order to generate more, we have different functions. Python. Okay, I never created a file for it. Let me practice in functions here as well. Just after it. So let's import random firstly. Then I'm saying random dot. See, it will suggest you the function. Inside it, let's see what is happening if I'm writing like this. Is there any something is wrong? So I need to pass two numbers firstly. That if I want to generate numbers, what are the limit? So let's say I want to generate random integer in this range. So output is only one. So this rand int is helping you to generate a single random integer in the given range. So when I wrote 5 comma 10, it gave me 8. Some random generated value between 5 and 10. In the same way, you can change it. You can write 500 to 1000. This is going to give giving you 714, a random number between this. So this was one example. Now the second example which we have here. What if you are writing random dot random? Okay. If I am writing random dot random, so this is randomly generating some numbers and it is not an integer. Here it was for integer because we wrote int. But if I'm just writing random dot random, then any random number will be generated and mostly it will range from here the range is given from 0.01 to 1 means it will be a float number from 0.0 to 1. It will always be lesser than 1 or equal to 1. Now, if you want a larger number, you have to multiply here with 100 or 1000. This is the only way to do it. Now, let's say I don't want to see this small value. So, I will simply multiply here with something like 100. So, this will give me 51 now. So, this random, what it is generating, can anyone tell me now? What is the range of this random function? I'm not asking about rand int. What is the range for this random? Tell me if you guys are hearing me. Good here. Okay, Kishan, you want to see more than one number? That's what you're asking? Yes, Piyush, correct, Praveen. You guys are correct. Okay. We should have the method. Let me check if it is mentioned or not. If it's not mentioned, I will tell you. So yes, this is all. You can multiply with 1000 and all to get the bigger number you want. Okay. Okay, that's one thing. Let me go to the next. Now this is what, let's say, I think this is what you guys asked me, RAND range. This will help you to generate the range of the numbers. So what if I'm doing something random dot, since they were giving a single output. Now I want to know, I want to see more than one output. I can write random dot rand range and we can give a range of the numbers. Start, stop. This will work similar to your range function. Let's say starting number is 10, stop at 100. Let's see. Oh, it is not giving me a series. Generate random numbers from a specified range. Rules from the steps. Let me write step. I thought it works for. Okay, give me a second. I'll check this. Using to generate numbers from 50 to 100 is random. 50, 100 and. Oh no, this is also giving a single output. Random value only it is coming. So do we have anything for more than one output? Let me check. Mostly they are giving single output. So whenever we use them now, basically we create a for loop so that the single values can be fed in each of the rows. So you might be thinking that then what is the use of the single value? So what we do, we created a loop. So for each of the rows, we will create a loop so that at one time, one random value is generated and feed it here. So in the first loop, let's say one random value generated, we feed it here. In the second loop, second random value generated and feed it here. So why in the same way, we should be able to generate this whole data by feeding single value at a time. Now this is one way to do because we are seeing we don't have any function that can generate more than one. You guys can check as well if we have. I don't think that's why I am not included here. Let me check. Okay, anyways, this random, this is how it will work. We discussed all of them here. Now let's see if anything else is there. Yeah. We are done with random as well. Next we have is exception handling. How many of you know about exception handling? Like share your ideas. What you, if you're seeing this word, then what you understood by it. Just write in chat. Okay, Prakash, that is correct. Yes, yeah, correct. You guys are right. Yes, Shamal. Tushar, great guys. Okay, okay, got it. Now let's see. Try catch whenever we know the block of bulletins and yes, yes, Anita, good. So let's see. Firstly, we need to understand the most common two type of error that happens in Python. Okay, first one is the syntax error. Once you have something, you have done something wrong while writing the code. You are not following the syntax of the Python, so you are getting syntax error. Second one is the logical errors. Logical means can be the exception. Means there is some issue in your logic, like whatever code you're writing, that might be issue in the logic itself. That is another thing that you have to check it. So, in order to deal with logical errors, we have some exceptions. Now, what is the exception? Like I told you, that there is a thing that we cannot divide a number by zero. This is a by default universal fact that we cannot divide a number by zero. It will return me undefined or infinity, right? But how Python will know this? If I'll do the Python, we need to see that how we are going to handle this. This is an exception, correct? So, in order to handle such kind of exceptions, we call it exception handling. So, you can like pass such kind of exception in Python. Let's say you're writing 1,000 line of code, and there is one way, there is one like one place, some error is coming every time. So, you just want to ignore it. So, you can use try except method so that this part can be ignored and rest of the things can run smoothly if they are not dependent on this, obviously. So yeah, so in Python provides you the flexibility to handle the errors. Some exceptions are there, some issues are there which cannot be executed. That is a universal thing that cannot be done. So you can easily handle them using exceptional handling concept. So as the definition indicates here, we can go through this definition once. An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program's instructions. So as I said, that let's say you wrote 1,000 line of program, right? And there is some exception at the 500th line. And it is disrupting the normal flow of my program. So what I can do, I can put it as an exception that, okay, ignore this part of the code and run the rest of it. So in order to do that, we can take help of this exceptional handling concept. So in general, when a Python script encounters a situation that it cannot cope with, it raises an exception. So the same thing, if you are writing a Python script, Python code, there is a situation that Python is not able to handle. You can raise it as an exception that, okay, this is an exception, ignore it, and we can proceed with the rest of the code. And this exception will help you to represent the error, that what error you have been getting here. So this is an exception, then this is the error. It can talk you here that, okay, this cannot be divided. This is zero division error. So in this case, we already have an exception made in Python that is known as zero division error. Whenever you will try to divide it with zero, it will return you zero division error. Means this is an error, you cannot divide by zero. So some exceptions are already made in Python. You can use it directly, or some you can create on your own using the syntax, which I will tell you in the next slide. Now this is the way to write the exceptions. Let's try to understand. First is try. Now this is what you have to follow. Try, except, else, finally. Try means run this code. Let's say some code you want to run. So execute this code when there is an exception. Now let's say I was dividing A by B. But I know that we cannot divide it with when b is 0. So exception will be here that b is 0. Else what? Else divide a by b, no issues, right? You can divide them and you can return me the output, and finally always run this code. So here is the exception we are giving. Basically, firstly we give a code to try. If this code is having some exceptions, then you can write here in this except. After that, else, if let's say if this exception is not occurring, then run this code normally, and finally, after passing through or you have to run this overall. So finally, always run this code. Now, any question you guys can ask me. Now let me check. Like, see, these are the common exceptions you will be seeing in Python. When you will try to divide a number by 0, this will appear, 0 division error. Name error will come when a name is not found. You must have seen this, right? Whenever you define a variable, you want to call it with different name. Let's say you define A and now you're calling AB. AB is not there, so it will come by default name error. So these are the common exceptions. Indentation error you must have seen. Whenever you give a wrong indentation, this will come. Then we have IO error, means input output operation fails. This you not have encountered yet, but you can get it once you are working on the file and everything. Then we have EUF. It occurs when the end of the file is reached and yet operations are being performed. So let's say you are reading a file and you have reached at the end of the file, but still some operations are being performed itself. So that is the error of EOF. Okay. These are the already created exceptions in Python, and you can create on your own. How you will be doing that? Just I showed you on the last slide. This is the way you can give your own exceptions. Give me a second, I'm getting a call. Yeah, okay. Let's see the next now. So how to raise an exception? This is the way you can try. As a Python developer, you can choose to throw an exception if a condition occurs. To throw or raise an exception, use the raise keyword. So we have a new keyword with the name raise. In order to raise some error, we can use it. Now let me see if I have a file on exception handling. There should be, we have. So let's open that file and we'll practice. Oh, here I have math and random modules in exception handling. Okay. You guys can see here. I thought that I don't have, but yeah, we have here in math and random. Here you can practice. Okay. Then we have exception handling. Now you can see this first one. I'm saying that x is minus 1. Then I'm saying that if x is less than 0, then raise this exception. So whenever this value of x, every time in your code, now this will be applicable to your whole of the code, where whatever you'll write below it. So whenever you will define the value of x less than 0, you will get an exception error. Sorry, no numbers below 0. So this is something error you created on your own based on some situation. Let's say in your code, you cannot have a negative number. There is some scenario that there should not be any negative number. So for that, you can raise this exception that if this value is coming negative, just throw me the error. Okay. So this is the exception it will come. Simple as that, the first code. So I will just paste it. If you want to try, you can try. Now what we have? The second exception, I'm saying that x is hello. And then we are having a condition that if the type of x is not int, not. See, if not type of x is int, then error should be that only integers are allowed. That means if you'll put any string value in this x, you will get an error here. And what is the name of that error? You are writing type error. Here what you wrote? Exception. You raise it here with exception. Here you are raising a type error. right? So based on your requirement, you can change it. Using raise keyword, you can raise some error. First of all, that error can be an exception. You can write it as an exception and then pass what the message you want to give. But if it is a type error, you can write type error and then pass the message. The same message will appear here whenever you will write something which is not an integer in X. So it will tell you type error, only integers are allowed. Now this is what I was saying, try, except, and else way. Let's say I'm defining a function a, b, y, a and b. What we want to try? We want to try c equals to a plus b divided by a minus b. Except zero division error. Now this is zero division error already available in Python, which I'm using it here. So I'm saying try this code, but the exception is that you need to follow zero division error. Whenever you get a zero division error, you have to print the output that a by b result is invalid, that we cannot divide. Else you can print the output of C, means in that case it should be divisible. Otherwise you can write that there is result is invalid. Don't write A, B, just write result is invalid. Then print C. If let's say you don't have any exception, then normally print the value for C, because in that case they will be divisible. Now we are calling this function by passing some numbers, let's say 2, 3, 3 and 3. If I will run this, first one will come fine, but the second one will be invalid. What happened here? Unrecognized run. See, second one is result is invalid. Why we got invalid? Because now this is 0. Because I have passed 3, 3. So a minus b will be 0. That means we are having the situation where we are trying to divide a number by 0. This is an exception. The exception name is zero division error. So I wanted to print result is invalid, so it came here. Now you can see you're not getting any error, but this one is exception. So this is the way to avoid the errors using try except method. We have user defined exception. This is exception already given in Python, right? Zero division error. Means Praveen, I'm not getting. Are you trying this code or you're not able to understand this? You're not getting. Okay. So I told just few minutes back that zero division error will come whenever you will try to divide a number by 0. You understood that or not, first of all? Whenever you will try to divide a number by 0, then you will get zero division error, right? This error is already created in Python to handle. That's why we are not doing anything, we are just utilizing it. We already have an exception in Python with name zero division error. So whenever you will divide two numbers, right, you can apply this exception. And it will check that this denominator should not be 0. If the denominator comes 0, then it will print whatever you want to see. So what I did here, I said that apply this exception in this function. Yes, correct. Correct, Shamal. So this is already there and we are just writing result is invalid. That means if you are getting an exception like zero division error, just print this. And then in order to check it, I gave the numbers 3 and 3 so that we can get that situation. Yeah, this keyword I told just few minutes back, na Praveen. Here we discussed in theory that this is the way to handle the error. I showed this one. See, try, except, else. We are learning exception, so we will get except keyword, right? You will get habitual once you start working on it. Okay, then it is fine. Let's see the next one. So this was already created exception in Python. What if you want to create your own? So that is the next example. Here we will be creating our own user defined exception. So how we are creating? Let's see. You will have to use raise keyword like we did here. Initially also we created some exception, but those were very easy. Here we will create a big one. And let's see. So what we are trying to do, we are defining a number to be 10. Then we are saying while true. While this is true, try out this. Try, except, we have passed two exception here. So we are saying that if your number, I number equals to int input, enter a number. So here Python will ask you to enter some number first of all. If your entered number is less than this one, what is defined above, whatever you are entering here, right? If that number is less than this 10, then the exception should raise a value like value to a small error. So this is the exception you are creating. It will raise an exception that your value is very small. Now, second scenario, if you are entering a number that is greater than this 10, then it will raise an exception value too large error. After that, you are breaking it because we are writing while true, it will keep running it. You can create an infinity loop. Then, after checking this, we break that loop here and then we are having exceptions here. So, basically, here we raise those exceptions and here we are calling them out. Raise is helping you to raise the exception. If you want to call them out, you have to write except value to a small error. And the message which you want to print should be here. Then except value to large error. This is the message you want to see. Here you raises the exception, but what the message you want to give in those scenarios, right? So that message you need to put here in the exceptions. So if this is happening, value to a small error, the exception should say this value is too small, try again. If let's say this second error is occurring, then the exception is asking value to large error, this value is too large, try again. And in case if not, if nothing is happening like that, you are entering the exactly number S10, which is there given here, then you will write, congratulations, you guessed it correctly. Yes, Shamal, you can experiment with range function instead of user and all. So see, this is asking me to enter a number. Let's say I'm entering 5. Now this 5 is a small than 10, right? So it will raise me what I did. So it will raise me some exception. Let me run it again. I think I did something. Let's say I'm printing the value as 3 and hitting enter. So I got some type error. Okay, let me check. Value too large. Yeah. So here you can say value too large error. This value is too small. Try again. Catching flash. No, I think there is something is wrong in the code. Let me check. Why this message is coming? Let me just refresh it. Yeah, this one only, this code only I'm writing there. We are missing something. I think one print statement is missing. If number is less than this, raise value to a small, break it. Now this except should be in range with this. Let's print again. What, Shamal? If we give the current bit, Shamal. Yes, that can be done. Correct. You can raise exception like that. Yeah, Rudrani. Let's check now. Exceptions must derive from base exception. Something is wrong. This one is using latest version. Sometimes this version issue is coming. So many things are getting updated in new version and the previous code is not running. Okay. That do not derive from base exception. We need to pass base exception here. Else, I need to write here maybe. This is parallel to it. Okay, I will check it. I will check it and fix this. It will take me some time to check what is new in the new version. What, Tushar? Okay, yeah. Yours is correct. I think you can try it. Okay, I will paste yours here. Let's see. Is it the same code or you have done something different? Mhm. Same, right? Sometimes Python behaves. Let's see if it is working here or not. Mm. Oh no, you're defining class. You're doing it with a class, right? I was trying with while. So firstly, okay, got it. This error you fixed it. Catching classes that do not inherit. Got it. Then it should run. Let's check now. Yes. So the thing is that now what they want, this code was running previously very fine, but in the latest version, they have made some changes. They are saying that catching classes that do not inherit from base exception, that is not allowed now. It is not allowed now. So what we are doing, we need to inherit these classes. Let's say if I'm raising this error, value to is small error, right? Or value to large error. So initially I need to create a class of it and then pass it. This class actually is a concept from object oriented programming of Python. But since we have not done that, I will not ask you to, go and check it as of now. It is just like you are saying that you are creating a class, means you are creating a base of it in Python firstly. You are defining it there, you are storing it there and then using it. So we are writing it class value to small error exception, value to large error exception. And then later on I can call those exceptions here because they are already created. So this is the new way to create the exceptions, value to small error, value to large error. And later on you can directly use them. You can see this is in black now. It is already defined here. So in that case, it is working fine. See, when I entered a number 5, it is saying this value is too small. Try again. Basically, it is a guessing game. So if I will write 11, it will say that your value is large. Try again. Once I will write 10, this code will stop. Then see, you can see this is stopped now and it is saying congratulations, you guessed it correctly. Okay. Keep both the codes as of now. I will see if something can be improved here on this without using class. I'll check it out if that is possible. Otherwise, you have to go with this class one. It is like just we are creating a base of it in Python. Instead of using it here directly, you have to create a base that we did using class method. Next we can check a value and we can raise an exception. Let me run this first leaf. Yeah, this is fine. So we can check a value. That value could be anything. Okay, Shekhar, I will paste it there. So I'm pasting the code of this class. You guys can try it. Next we have check value. You can check any value using this function. If this value is less than 0, it should raise you an error. Value cannot be negative. Otherwise, it should return you that particular value. Simple as that. Now after doing that, you are trying it here. You are trying it on a result where you are writing check value -100, print result. Accept value error as E, caught an exception. So whenever you will put a value negative here, you will get this message. So when I put -100, you can see I got an exception because value is negative. But if I'll put something like positive, let's say 10 only, then in that case I will get the value as 10. Because if this exception is not there, it should print me the output as it is. Go through this code, ask me if you have any doubt in this part of the code. This as well, Piyush, you want me to paste this one as well? Okay, done. Now the next we have assertion in Python. Assertion in the sense like we can give some condition. It's okay, Shamal, if you're not able to copy. I will. You must have this notebook, or I will share it today, and then you can do. So, what is an assertion? Assertion is just a statement that will test the condition of your code. Condition in the sense, if it will help you to check the condition, and if this condition is not satisfied, then you will get error. Ma'am, one doubt where we use in data analysis and data science. These things, Prakash. Yes, Prashant, they will share these files in LMS, correct. So, Prakash, these things will help you to write the code efficiently. So once you will start working in data science projects, now you will have to create models and everything. So if you have knowledge of exception handling and assertion, so while writing the code, you can ignore few part of it. Let's say if you're getting error again and again, you can handle them. That's why it is important to know these concepts as well. Okay. So Shamal, there is not a definite rule that you should have at any interval. Yes, Prashant, I already have shared a previous one. This one also I will share. So it depends on the requirement. If you want to assert some condition at some particular scenario, you can use it. There is nothing rule that. So one function completes and then we do it. Yes, yes. You have to check some condition, right? There should be something to check on that some value is true or not in your code. After writing some piece of code only, you will be able to check it. Correct. So how we are doing it, this assertion, see, you have to pass some condition. If it is true, then only you will go to the next line of the code, right? Otherwise, your program will stop there itself and it will show you assertion error rest. Yes, that was different. This assertion is different. It will check the condition, it will stop the code there itself using assertion error. Because let's say something important is there, and without that condition, this whole code will not make any sense. Not make any sense, right? So what we want is that it is very important now to check that critical condition in my code. Without that, we cannot go ahead. If that critical condition is satisfied, we should be able to run the rest of the code. Otherwise, we have to stop it there itself. So that's how assertion will help you guys. So we can test the trueness of a condition in my code. And this is a Boolean expression. It will return you true or false. If it is true, you can move, otherwise. So let's see the code for it. So we can have assertion in different way. Either you can give assertion with an error message or without an error message. So the first example here is without error message. So I am saying defined average marks, assert length of marks not equal to 0. So what is the condition here? That you length of the marks. Means if you are putting some marks, the length of it should not be equal to 0. It should not be equal to 0. Means this condition should be true in order to return some value, right? So I'm saying mark 1 is equal to empty list. Now if you see this is an empty and the length of this marks is not equal to 0. This condition is not satisfied here because this is equal to 0. The length will be 0 of this list, right? So if I will try to get the average of this mark, I will not get the average. Instead of that, I will show it will show you an assertion error. But there is no any message. If you see after this assertion error, there is not any message. So this is an assertion error without message. Can we have -1? It is about length. It is not about value inside it. Length will not be -1, right? Length will be 0, 1, 2, 3, and so on. This is similar to try catch to avoid error. Yes, try catch. Yes, correct, Ravi. I agree with that. Try catch will also able to catch the error using raise and all, and it is similar. So basically, this works for the Boolean output only. That is the main difference. It will always return you the output in true and false. If it is true, the code will run. Otherwise, not. Let's say now I am putting value like 1 comma 2. Now I will not get any error because this length is not equal to this condition is satisfied basically. So it ran here and it returned me the average marks, that is 1.5. So 2 plus 1, sum of marks divided by length of marks, right? So this is how it will work. This was without any error message. Now let's see one example where with this assertion you can give some error message as well. So here what we are doing, we are saying define percentage of marks. For m in marks, assert m is greater than 0. So now I want to calculate percentage of all the marks. So these are the different marks we have. I have to calculate percentage of this marks, but the situation is that each of the marks should be greater than 0. I initiated a loop to check each of the marks here, and I'm saying that for m in this marks, assert m is greater than 0. So if this condition is true, then only this will happen, the next line. Otherwise, you will get an assertion error with this message, only positive values allow. So if I'm running this, And there is a negative marks here, you can check. So I got an error, assertion error, and this is the message we have. Previously, if you check this example, after this, no message. But here, after giving comma, you can give a message in a string format and it will be appearing here. So these are the errors you can create based on the condition in the code. Any doubt? So we are done with the assertion as well. This is not included in your this syllabus. Let me check once for you. I'm sure it was not there. Let me just confirm. This was in previous batch, that topic. Still, it is in your PPT. In case if you want to go through it, you can go, but it is not part of it. I'm so gone. Yeah, see, the last topic is exception handling. So we are done with this Python part, modules, math, random exception handling. Prashant, it is not required. That's why they removed it. I will tell you why. Because these things, now, since we are from the data science, so we don't need to use these operations as much. Why? Because we'll be using pandas to handle the files. We have different libraries, so these Python file handling operations will not be needed for data science. I think that's why they removed it. But if you're someone who wants to go for developer position, for Python developer, Python engineer, then you should go through it. But since you guys are focused on AI and data science, don't require it. It is not required at all. So you can ignore this one. Make sense? Great. Now next what we have, advanced Python packages. But before that, as I promised previously, we will do this statistical thing. Where was it? Huh? Since you know how to understand the Python code, you can understand the syntax and everything. So now we can see inferential statistics and this descriptive, whatever we did previously, right? We'll practice it in Python as well. Before that, let's take a break. It is 11:30. We can have a break of how many minutes? 5 minutes? Okay. So let's have a break. Okay, let's keep it 7 minutes. Okay, Piyush? Hi guys, I hope you all are back. Okay, Praveen, you're saying that you don't have, yeah. So in that case, I will suggest that start with the data analyst. As I always say, for the people who are new and they cannot, in one go, they are not ready to catch the things in one go, like machine learning or advanced things, then start as a data analyst. As a data analyst, you will gradually learn the rest of the things as well. Because in any company you will go, they will suggest you to upgrade yourself of a skill. There you can do. But initially, make sure to be good in Python, SQL, and then any one visualization tool like Power BI, Tableau. If you are doing Power BI, na, that is also enough. Lot of opportunities are there outside in Power BI as well. So yeah, let's see the next now. So I was about to tell you that we'll now cover that stats part which was left initially. So let me upload the book. So we have three implementation: descriptive, inferential, and probability. Firstly, we'll start with descriptive stats. How many of you remember about descriptive stats? What things we saw there in descriptive? None of you remember? Yes, Kishan. Correct. So in descriptive stats, yes, here. Basically, we are interested in knowing mean, median, mode, standard deviation, variance, right? And then this count of the data, how many values we have in a particular column, and at extra. We have seen it in our statistical theory. Here we are gonna apply in Python how to get it done, how to get these values in Python. So for that, this is the Python code. Let's say we are starting with the basic one. We are importing NumPy as NP. Now, why I need NumPy? Because this mean function, in order to calculate mean, it is available in NumPy library. That's why we need to import NumPy firstly. Then we can use it here. See. So let's say this is the data I have, very small one, 10, 20, 30, 40, 50, and I am writing NumPy dot mean of this data. And then I'm printing that mean. So this is how it will come. You can cross check the mean of this data is nothing but 30. So we have got the output as 30. It is running. Yeah. So we got 30. Next thing, next thing was median. This median is again available in your NumPy library itself. So we need to write NumPy.median and then this data. If I will run this, I will again get the output as 50. Next we have from scipy.stats import mode. So now we are importing mode. What is mode? How many of you remember? See, this mode was not available in NumPy. So we have to make use of SciPy library. SciPy is similar to NumPy, but it is the advanced version. Yes, Anita, Praveen, and Sekar, correct. So mode will help you to know the number which is repeating the most. Here 2 is repeating most of the time, highest number 2 repeated 2 times. So the output will be here mode. If I am printing, it will be 2. If I will write it, let's say I'm writing 3s like this. Now what is mode here? In SciPy, okay, I forgot this comma. In SciPy, right, we have different functions available. Here I am using it for mode now. If needed, later on I can use it for other functionalities as well. So whenever needed, I will tell you that what is that. Basically, statistical functions, right? All the statistical functions are available in SciPy. So whenever we have to use, we can get it, import, and we can use it. So now next we have standard deviation. In order to calculate in standard deviation, it is in there in NumPy itself. So we can write numpy.std data. So STD stands for standard deviation on this data, and then again we are printing it. We are using F here. Why? Because this is a formatted value. It should come from here. So when I'm running this, I got a standard deviation like this. Next we have from scipy.stats import skew. How many of you remember skew? Skewness of the data. Remember it? I showed you some distributions. One was like this. One was like this. Yes, correct. Left skew, right skew. Positive skew, negative skew. If your skew is coming out to be positive, is it left or right? Who is going to tell me? Tell me for positive what it will be. Is it correct, whatever I'm writing here? Yes. Good, guys. So now we can use this skew method to get the skewness of our data. Let's say if you are getting a positive value here, you can say that this is a right skew. If you are getting a negative value, then you can say this is a left skew. In this one, I have told you in order to check right skew, always look for the tail. If this tail is lying, if this long tail is lying on the right side, so it should be your right skew. Correct? If your tail is lying, long tail is lying in the left side, it should be left skew. Okay, great. Since you guys remember, I am happy. So now we can calculate this skew by using this. We imported this skew from scipy.stats. Since this skewness is the property of statistics, so it is available in scipy.stats. Then we applied it on our data, and whenever I will run this, I got a positive value. That means it is a this is showing a positive distribution. Okay. A positive distribution in the sense right skew. Yeah, correct. Now kurtosis. How many of you remember about kurtosis? What kurtosis does? So write quickly what it does. Is it correlation? Someone is writing correlation. Yes, this is no, not correlation. This is about the peak of the graph. Correct, Kishan. So here we can check how this peak looks like with the help of kurtosis. It might be very sharp, correct? It might be normal or it might be blunt. Blunt means it will just go like this, no uniform. And this is the normal distribution, means our normal case, neither it is blunt, neither it is sharp. So with the help of kurtosis, we should be able to find it out that how the peaks look like. And here you can apply it on the data. And again, based on the value, you can judge it whether it is positive, negative, or zero. Positive, sharp, negative, blunt, zero means normal. So we got negative here, right? So this is about your skewness, kurtosis and all. Next what we have is range. If I want to, yes, correct, leptokurtis. Very good, Shaman. You remember that name. One was lepto, other one was, what was the other one? Who is going to tell me? Platy, is it correct? Hmm. Very good, guys. Yeah. Okay, here. Now, in order to get the range, let's say I have a data 1, 5, 10. You tell me, Piyush, because I already have taught here. That's why I'm not telling anything. Only you guys are telling me the answers. Theory is done. I'm just saying, telling you how to apply in Python. So what is this? This is Platy or Lepto? Find it out. You can check your notes. It is there. Now what happens? Okay. Yeah. Very good then. Platy. It is negative, so it is Platy. Very good, guys. Yes, if it is not installed Pranjal, you need to install it. You can write pip install SciPy. In Google Colab, not needed, but in your Jupyter or some other tool, you might need to install. So this is the way you can do. Can we have other libraries? Do we need to install? One time you need to install them. By default, some of them are already installed. If not, you have to do. So you will get it once you will run the code. Now it will ask you that this is not available. This library does not exist. Something it will show. Names of other libraries which you need to install. So very famous, I told you, NumPy, Pandas, Matplotlib. Add here SciPy, NumPy, SciPy, Pandas, Matplotlib, Seaborn, Scikit-learn. This one we can do later as well, scikit-learn, once we'll start machine learning. Math module, import, random module. Yes, Seaborn, correct. Spelling is correct, Pranjal. Matplotlib, also add Matplotlib. Okay, I'm writing in the chat. Give me a second. Py, SciPy, Pandas. Then you can import math as well, random as well. And there might be something I'm missing. Let me remember. NumPy, SciPy, Pandas, Seaborn. You can add scikit-learn as well. Scikit-learn. Yeah, for now this much is fine. If something else needed, we can add. This should be there, basic. Now, in order to get the range of the data, like what is the range value? If I'm having 1, 5, 10. So what is the max and then min? Basically the difference between the maximum value and no. Not in the CMD, Praveen. If you are writing pip install, you can directly do it in Jupyter Notebook itself. For CMD, it will be different. This one you can do with this exclamation, you can do in Jupyter itself. You don't need to go to CMD prompt. For that, it is syntax is different. Anyways, let's see here. So range of the value. Let's say I'm writing 1, 5, 10. So range means the difference between the maximum and minimum value. So here maximum is 10, minimum is 1. So range will be 9. Simple as that. So this is the way to get range. You have to subtract maximum minus minimum. You need to do that. Next we have import numpy as NP. It seems like that, Pranjal. You can write it. Not much of them. Okay, let me continue here. You can please write it there. Now we have, in order to calculate variance, I have told you, I have shown you, right, for standard deviation STD. In the same way for variance, you can use numpy.var. This is the way to get the variance of the data. So we are doing it because it is the part of the descriptive stats. So you can write numpy.var. Then the next what we have? Next we have coefficient of variation. This one also I have told you. Please go through the theory if you don't remember these things. These are the basic part of the statistics. Everyone should know. So in this one, you have to divide the standard deviation with the mean basically. Then you will be able to calculate coefficient of variation. How many variation is there? If there is some variation in the data from the mean, then how much variation is there? So it will show you in percentage itself if you will calculate here in percentage. So I have calculated this value in percentage if you see, because I have multiplied it with 100. So now I have got this coefficient of variation in percentage, that there is a variation as 44% in my data, around 45 like that. So what we did here, we use NumPy to get the mean. Then we use NumPy to get the standard deviation. Once we got these two, we divided standard deviation by mean and then multiplied with 100 because I want to see the value in percentage. Simple as that. Next what we have? We have Pearson regression, Spearman, correlation. How many of you remember what is correlation? What is correlation? I am not asking you Pearson or Spearman, just correlation. Remembered? Okay. Now in Python, in order to calculate the correlation, right? We have got here, you can see two examples is written, Spearman and then Pearson. So we can calculate using any of them. So how are they? Let's say if you want to measure linear correlation between two values, two variables. What happened, Pranjal? How things are related together? I'm not getting your question, sorry. Ha, okay, okay, I got it. You are telling me the definition of correlation. Yeah, okay, correct. I lost it. So yeah, here I am. Ha ha. So Pearson R, Spearman R. This is a like the name we have, the defined keyword we are using to calculate the Pearson correlation and Spearman. And where it is available in scipy.stats. Again, we are using scipy library because these are the part of the statistics. So we are writing .stats. Okay, these are defined things. I'm not writing it on my own. These are already things are arranged. Like I told you, right, that there is a library. In that library, we have module. So just like that, things are arranged there. I'm just picking them and using them. So these are the functions available in this library, in this module. SciPy is a library, stats is a module. In that module, we have these two functions. Now I'm going to use them. So for that, I'm writing Pearson correlation. I'm giving an, what is this? What do we call it? Hyphen? No, not hyphen, underscore. You need to type from the module every time. Once you imported in your code, you don't need to do it again, Pranjal. Only one time it is needed. But if you have different script, different file, then again in that file also you need to import it once. Now what we have, yes, we'll need to remember which belongs to which. Yes, you will remember it with the practice. Otherwise, just Google it. There is no issue. Even in interview as well, if they will ask you to write the code, your basic one you should remember. But let's say something higher is there, you can ask them. You can Google it. You are free to do that. Yeah. Now what we have. I was talking about this correlations. Now this is only for, we have Pearson and Spearman. So first thing is that what is the difference between them? Because they both are calculating correlation, right? Then what is the difference? This is for continuous variable. Now you should remember what is continuous and what is ordinal, nominal, right? And this can be for both continuous or ordinal. Ordinal, you guys remember? When the data is given, let's say 1, 2, 3, not 1, 2, 3, I will take some categorical example. Let's say it's written high, low, medium. Now this is an ordinal data. It can be in an order. Low should be 0, medium should be 1, and high should be 2. So this Spearman correlation can find correlation between such type of ordinal data or for continuous data where you have continuous values 2.5, 3.9 like that. Basically float values. So Spearman can be applied for correlation in both the cases, but Pearson is only for the continuous one. Okay. Only for the, it will be able to give you the correlation between continuous variables. But the Spearman can give you the correlation either between correlation or ordinal as well. There is no restriction here. Okay. So this is a way to apply it. Pearson XY, Spearman XY. Right. Now we can just run it and we can see this correlation values. If it is negative, that means they are showing a negative correlation. And we can see that there is a negative correlation in our case. So you applied both of them and Pearson is more accurate. Like it is giving you value up to more decimal places. However, Spearman is giving only till 1 decimal places. So more precise will be this one. Right. And one more thing is that based on the assumption also we have some difference. This Pearson will assume that we have linear relationship always. This is the assumption we have. for Pearson. But for Spearman, it will assume monotonic relationship. Now, what is monotonic relationship? You can search it out. You must have heard this word, right? Monotonous, right? It is based on that itself. Monotonic relationship. Linear relationship, monotonic, only singular, right? So that is the assumption. Anyways, this is the way to calculate it. Then next we have covariance. Again, we talked about covariance as well. After correlation, we also saw covariance in our theory. Here, if you want to calculate covariance in Python, you have to write NumPy. And in Excel, we already have seen how to calculate them, right? So for Python, you have to take help of NumPy library. You need to write numpy.cov. So it will return you covariance. Here you have to pass. If you want to get the covariance between X and Y, pass them here. And also I am writing 1 and 1. Now why we are doing that? Let me show you. If I am not writing this 1 and 1, right? Let me just copy this code. Let's say I am not writing this 1 and 1. I will remove it. So I have got something like this. Because covariance is a matrix. Covariance returns you a matrix that is having 4 positions. So for this, a bit theory is needed. Does anyone remember what each of them indicate? Yes, Pranjal, it is not needed, but just for the standard part of the code, I have included everywhere to indicate that we need NumPy library for this block. We need SciPy for that block. That's why I am writing it. But if it is done one time, it is not needed anymore. Oh, you are saying Y and NP. You can write anything. See, NumPy, I already have told this one, Pranjal. Why we do that? Because this is a very big name. You cannot write it again. Yes, exactly. You know the answer already. So just to make it short, you can keep any name, right? These are the standard names. Oh, so what I was asking, yeah. So we have got a covariance matrix here. Does anyone know what they do, this matrix, what this will have? Mhm. Okay, let me check. What is the Q? Oh, what is the question? Question was that you can see that I'm getting a when I'm writing numpy dot covariance x and y, I'm getting this matrix I'm getting that is having value 1 minus 1 and 1. So my question was that what they indicates, what these four values indicates. So diagonal like these values will indicate you. Yeah, you can relate with the Excel file from the cells, right? They indicates the variance basically. They will indicate you the variance of x and y. These two. And then we have got off diagonal. This is the covariance. This they will indicate the covariance. So we have variance and covariance which is represented here. But this is a covariance matrix, right? This is a covariance matrix. But I am writing 1 and 1 here because I was interested in seeing that covariance value. I am not interested in seeing this variance that is minus 1. I just want to fetch the covariance value. So that's why a straight line angle related 45-degree. Yeah. So here, sorry. This is a covariance matrix. If I'm printing this also, I should write here covariance matrix, not the covariance. Okay. So this is the covariance matrix. And here also you should write covariance M times M. Okay. But so these are indicating variance. I'm interested in the covariance value. Did I wrote it ulta? I mean, this minus 1 is the, what we say, variance, then covariance is the plus 1, x and y. So here I am writing 1 and 1. That means I have to go to index number. I hope you know, right? Slicing thing. So let's say if I have a matrix with some values. So if I'm saying 1 and 1, that means firstly we have to go and check the row numbers having index value 1 and then column having index value 1. So I think this was plus and this was minus, like this. So if this is plus, this is the covariance value. If I'm saying x and y 1 and 1, so go and check the row which is at index position 1 and then go and check the column which is at index position 1. So I will get this value 1. So the answer is 1 here. It's correct only, na? Shamal. Seedha means this is a index position for row. This is for the column. Next, what we have? So we have seen like some errors calculation. That time we have not discussed this. I remember that time we have not discussed this. I said that we'll be using them mostly in machine learning. So here I will tell you what they will do basically. What happened, Kajal? So see, covariance definition, I'm expecting that you know. If you don't, please go and check the theory. That I will not be able to repeat. Sorry for that part. Second thing, here we are just checking how you can get the covariance value in Python. Okay. So in order to do that, you need NumPy library. So we are writing numpy.cov x and y. That means I want to get the covariance between x and y. So we are writing it like this. But this part will return you a matrix. This will return you a matrix that is having value something like this. These values, two values will be your variance, two values will be your covariance inside this. We are only interested in fetching covariance value, this one. So in order to do that, we are slicing it. Now this is also something I already have told in list slicing part, that how you can fetch a value using slicing. So in this slicing, I am writing 1 and 1. This indicates firstly you have to go and see the row with index number 1. So this is having 0 index number, this is 1. So we are selecting this row. After that, I am saying go and fetch the column with index number 1. So this column is having index number 1. So what is the item will be picked here? Row 1, index column index 1. So 1 will be there. So we got the output as 1. That's it. Okay, Kajal. Now, next what we have, this one. So I was talking about the different metrics which we'll be using in machine learning to evaluate. Let's say we have to make some prediction, right? Let's say I have to do weather prediction or anything. So I want to see whether what we are predicting is correct or not. So in order to check them, we have these metrics which will tell us that what is the error basically. What is the error in our model? This metrics will help us to get it. So MSE means mean square error. No, Bhupendra, but this is the part of the statistics, so I'm telling you so that you can relate. If I'll just tell you this, you will not be able to relate it. So I'm relating it that where we'll be using it. Okay. So mean square error will help you to evaluate the error when you are making a prediction. So what is the error? So what is the formula for mean square error? So you have to, let's say your actual value is x and predicted is x bar, let's say. So you have to get the difference between these two, then take the square of it and then divide with the total number of data points which you have, like 1 by n. So this is the formula. See what I've written here, numpy dot array actual means actual value minus predicted value. This is the predicted, this is actual. And then once you subtract them, take the square of it. So we have taken square and then numpy dot mean. We have to take mean. So in order to take mean, you have to divide it by n, right? So this is the formula for mean squared error. So you have to define it here and then you can calculate it. Similarly, we have root mean square error. Root means it is just the same formula. You have to just take the square root of it. So that's why I have just added sqrt from numpy. Numpy dot square root msc. Can you tell me one more module from where we can use square root? One more module we have. And today only we discussed about it. Good. Yeah. Yes, second, correct. That is math module. Okay, someone said, who said that? Shamal. Shamal, you write sci-fi. Is it possible to do in sci-fi? Anyone? What do you guys think? See, sci-fi is like an advanced version of the NumPy. So where we don't need these things, right? We have to do advanced operations there. Okay, it's okay. You should know. So, but I think the square root is available. Let me check. No, no, no. I maybe you're right. Let me check. Some functions are repeating in most of the libraries. Let me check it once. So we already have imported it, right? Scipy dot square root. Let's say I'm writing 9. I have imported it now somewhere. Do we have it in stats or where? Oh, it is not defined. Okay, let me import it again. Oh, it don't have any attribute. I don't know why it hit me that it is having. It is not there. Okay, anyways, I was just checking it out. So it is in NumPy and Math. Okay, we can do it in NumPy and Math. It is not available in SciPy. Fine. So this was the formula. We take the square root of MSE to get RMSE. It is available in Math and NumPy. Sorry, what I'm saying. It is available in Math module and then in NumPy as well. Not in SciPy. So we got this. Then we have MAD. What is the meaning of MAD? Any idea? How much value is deviating from the mean? So here, see, this is the absolute deviation. Okay, this is the absolute deviation. That means I'm not taking any square and all. If you see, this formula is simply showing you absolute means again I have to take absolute value should be just, even if the deviation is negative, absolute will return you 3 value. Let's say it is -3. If I'll take absolute of it, it will become 3. Today only we discuss this as well. So this formula is like actual minus predicted. Let's say this is predicted. Take the absolute of it and then take the mean. So I will add summation here because we have to do it for all the data points. So it will be like this. This is a formula. So we have to take the mean of this absolute deviation. So that's why numpy dot mean, then numpy dot absolute of this value. Actual minus predicted, take absolute, divide with n. So this will give you mean absolute deviation. So this also helps us to calculate that how much variation is there from the mean value, sorry, from the actual value to the predicted. So these are the different metrics we'll be using. So with that, we are done with your descriptive stats part. Next, we'll check for the another one. What is the name of another stats value? Which we have done another stats. Two statistics are there, descriptive and yes, correct. Inferential. Very good. So next we'll discuss about inferential. So you must have seen there t-test, right? One sample test, two sample test. Then we have this. This one I think we did it or not, I don't remember. So I've added theory here. In case if you have not done it, you can check it out. That is chi-square test. Then we have ANOVA, analysis of variance. I think someone asked me that, ma'am, this is not done. So I left it for here only, ANOVA. After ANOVA, we have critical value tables, which is there in your theoretical PDF which I shared. This table is already there. And then we have confidence interval. and then one hands-on to apply them all together here. Just a small example. So let's get started with the t-test. How many of you remember what was the usage of t-test? Don't tell me remember, just write the answer there. What t-test does? What t-test does? Okay, Prakash. Any other one? It's an open question to all of you. Yes, that is correct. That is correct, Prakash. So let's say we have two groups. Even for one sample also we can do. So if you have one sample, you can compare the mean of this sample with the population mean. Let's say you have a population here. You can compare their means, right? So t-test comes in three forms: one sample, two sample, and paired t-test. So this t-test will help you to understand how much one sample is varying from the other in terms of the mean. We will compare their mean values using some formula and we can check it. So you can do with a single sample, double sample, or you can do paired t-test as well. So how to do that? Let's see one by one. Let's take one example here. Firstly, we need these two libraries. So we are importing it, numpy and scipy.stats and stats. Then we have an array, numpy.array. And this is one sample of the data I have in which these values are there and the population mean is given to be 60. This is something already given to you and one sample you have it here. Then you can compare, you can do one sample t-test, you can compare the mean of the population with the mean of this sample. And how to do that? So since you have imported this stats, right? So you have to write stats dot t test one sam. Now this is the reserved value. Like this is how it should be written. You cannot change it. This is a reserved word in Python. You have to write it in the same way. T test one sam. This indicates that you are doing t test underscore on one sample because it is for the one sample. So you have to write t test one sam. After writing it, here you need to give the sample 1, which is here, and then pass the mean of the population so that it can compare. So once you give sample 1 and and then the population mean, after that you can see the t-test values. So in order to print it, I have just added some things like one sample t-test, and then I have given one line here using slash n. This indicates the next line. So that's why t statistics is printed in the next line. And here is the t-test value and p-value as well. P-value also I have defined hypothesis testing. Prashant, bad one. I was not expecting that. I was about to ask you guys, what is p-value? We have done a lot of the things in statistics. This is a very basic thing. In hypothesis testing, we have seen this. This is probability value. Probability value. P-value is probability value. And based on that value 0.5, 0.95, if you guys remember, we were rejecting or accepting a null hypothesis. Alternate hypothesis. Yes, now you remember? Great. So yes, that is what we have. 0.05, sorry. 0.05. Now what is the next I was saying? So we did one sample t-test. It will compare the value. If you are getting a negative value here, what does that mean? Any idea? If t-test is negative, what does that mean? Yes. Reject. Mm-mm. No, no, it has nothing to do with rejecting and accepting null hypothesis, guys. I'm asking about t-test, not p-value. Ignore the p-value as of now. If this t-test is negative, so basically why we are doing it? We are comparing the mean value of the sample with the population. Yes, correct, Prakash. Very good. So it indicates that the sample mean is less than the population mean. If this is negative, it indicates that the sample mean is less than the population mean, which was given to us to be 60. In case if it was positive, that indicates that your sample mean was greater than population mean. That's it. Okay. And if you want to understand the statistical significance, then you have to look for the p-value. This will just tell you the deviation part. So if you want to understand, if you have to reject or accept something, that the difference means it is statistically significant or not, then you have to look at the p-value and then you can decide, which we already have talked a lot about it. So I will not repeat it here. Yeah, Prakash, you can use it there. Now next we have two sample t-test. So sample 2 is having some value. Sample 1 is already defined above, okay? Now I am creating one more sample. So this time I will create the mean of the two samples. Sample 1 and sample 2. We don't have any population here. We'll just comparing these two. So for that, what is the keyword you will be using? So you have to use, I will tell you at the end of the session, Shamal. So you have to write t-test ind. T-test ind. This is the keyword to compare the samples, to get the t-test for two samples. T-test ind. For that, what we wrote? We wrote t-test sample 1 something, right? Here you have to write t-test ind, pass both samples, and then you will get the output. Again, it is negative, indicating that the sample 1 mean is less than the sample 2 mean. Whatever you will write first, the value will come with respect to that. Then p-value is also very low. Okay, so p-value is very low, we can reject the null hypothesis, correct? Oh, yes, Prakash, you can try it out. Now we have paired t-test. Paired t-test will help you in the situation for the before and after. Let's say you are giving treatment to someone, some treatment you have done. Initially, can you see that this is an integer, Shyamal? Do you think this is an integer value? Tell me one thing. What is the range of p-value? I told you p-value is a probability. How it can be integer? It will be between 0 to 1. Let's say if 100%, then only it will be an integer one. If 0, then it is an integer. Mostly it will be a float value, right? It is not supposed to be an integer. At 5%, we were rejecting the null hypothesis. So this is a float value, right? Okay, great, you got it. Now paired t-test will be using for the comparison for before and after. Let's say before some values were different and after some time, it's okay, Shamal, it happens. After that, you got a new value. So now you want to get this pairing for the same sample is changed now. Same sample is having value something else, and after applying some operation, let's say that value got updated. Now you want to compare before and after, so you can use paired t-test. This paired t-test will help you again to understand how much mean deviation is there between these two. So you have to use REL here, t-test REL. These groups will be related to each other, so it is REL. Why they are related? Because they are before and after, it is same one that has been changed. So that's why we will be writing t-test REL before after values, and again we can understand, we can pass the values here. So before mean is lesser than the after mean, again it is negative, so you can make interpretation like that. P value is also very low. Yes, it is also known as dependent or matched pair t-test. You can call it dependent. I remember matched something, matched pair t-test. Yes, correct. Now next, this one, chi-square test. Till now we have seen that we have been working on the numerical data for these tests. What if you have categorical data and you want to compare their mean, right? that how much they are varying from each other. So for that we have chi-square test. This is a statistical test for the categorical data. So if someone is asking you the difference between t-test and chi-square test, the main difference is that this chi-square test is for the categorical data and this one is for the numerical. Since it is for categorical, so categorical will be like male and female, likes and dislikes. It should be like that, right? So we can work on that using by importing this chi-square to contingency. So this is the keyword, like this is the name of the function you have to use basically, and you have to import it from scipy.stats. So chi-square to underscore contingency. Apply your data here for male and female likes and dislikes, and then you will get this. This is degree of freedom. We already have discussed degree of freedom, p-value, chi-square test, and then the expected one. 4 parameters it will give you. It will give you 4 parameters. So if I'm running this, I'll get it. Now based on it, see why I am getting expected and all, because based on this itself, we should be able to reject the null hypothesis or we should be able to accept the null hypothesis. So based on the p-value, 12:30 Tushar, usual timing. What is the usual timing? 10 to 12:30, right? I will end it at 12:30, don't worry. So this is what I have got. And degree of freedom is 1. So again guys, I will tell you, just go through the statistics theory, then use this notebook. I will share this notebook today. Before practicing it, please read the theory once. Then you should be able to relate it. We already did all these things in our Python, Excel. I just wanted to show in Python as well. So we are doing it again in Python. Okay. So this is how it is. And I have told you that if p-value is less than 0.05, you have to reject the null value. So here it calculated the p-value, and based on this, since it is less than 0.05, we rejected, sorry, is it less than? No, it is not less, sorry. It is greater than 0.05, right? So failed to reject the null hypothesis. This is what we have got. No significant relationship found. So that means between these two categorical group, we do not have any significant relationship. No significant relationship found. And if you are rejecting the null hypothesis, that means there is a significant relationship. And we were able to check it after calculating, after doing chi-square test and after getting the p-value. We did that. Next, we have analysis of variance. Till now, we have compared mean and all, right? We have been comparing mean value. We have been seeing the things. We can also do the analysis on the variance as well. What this one will do? It will help you to analyze the difference between the mean of more than two groups. So since it is written variance, but again we are taking the help of mean because somehow mean and variance are also related. So ANOVA is known as analysis of variance. Until now you have seen that we were able to compare the mean for maximum 2 samples. With the help of t-test, you have done this analysis of mean for 2 samples max, right? Here also. If you have to do for more than 2, then you have to use ANOVA. Now you got the difference between 3 of them. See, t-test you can use for comparing the mean of 2 groups only. Either one sample, one population, or 2 groups or 2 related groups before and after. But let's say in case if you have to compare for more than 2 groups, then you have to use ANOVA. You can see now you can compare 3 groups as well here. Okay. So in that we have one way. You have to import F1 way. This is one way ANOVA we call it. And here you have to use one independent variable. If you will use two-way ANOVA, you have to use 2 independent variables. Now what is independent variable? Independent variable is something that is not dependent on the rest of them. That is having its own value. It is not dependent on any other values. So here we have taken 3 groups, group A, group B and group C. We imported one way ANOVA. Now we can apply on these 3 groups, and again we can check that whether how they are related, what is the value for it, and whether we have to reject the null hypothesis or not. So here we are rejecting the null hypothesis. Why? Because this value is less than 0.05. That means at least one group mean is significantly different. So since we are trying to find out that whether these groups are same or not, whether they are related or not based on the mean value. So we are rejecting the null hypothesis. That means at least one group mean is significantly different. At least one of them is different from the rest two. If it is failed to reject, that means there is no significant difference, means all the means are similar. Then we have critical value tables, confidence interval. Okay, it seems like we will not be able to finish it today. So critical value table will help you to understand the critical values which you can have in the different scenarios. So for that you are importing norm, t, chi-square and f, the functions which we have used there, right? So you will get the z critical value, that what is the critical value for z test, what is the critical value for t test, what is the critical value for chi-square test and f. See, in our scenario we can have different critical values. So you can just give, you can pass the, let's see, if you'll change degree of freedom and confidence interval, that is normally is 95%. If you will change them, then you can get different critical values. And why they are needed? These critical values are needed to compare. So if value is greater than critical this, then mean are different or mean are same, like that. In order to make the compare, we need these critical values. Normally the table will be given to you, but I have done this here to show you that in Python, this is the way you can get the values as well without table. So you just need to pass here normal.ppf, chi-square.ppf, t.ppf, means whatever test you are doing, add ppf there, and then give the confidence interval. That is 95% mostly, but we can change it as well. Like I've given 97.5% here. And then tell the degree of freedom, which you should know. Just revise it if you don't know in all the cases, and then you can get the critical values. That's it. Oh yes, you can do on that as well. See, the critical value is something that you can calculate. It is independent of the data, first of all. This is just a criteria you are passing. Okay. We'll be applying all this on actual data too and analyzing it. So here, yes, we will do it. See, not all of them. We will do in the model whatever is required. So basically, we'll be doing this test in EDA. I will show you the next topic will be EDA itself. That is exploratory data analysis. Since you learned about these libraries and all, now you will see how to apply on a real data. That we will do one case study, and there we will see how these things are helping us in real life. Yeah, practice is necessary, guys. So let's wrap it up here, okay? Next topic is that only, Vipendra. Please revise, please revise Python. Then it will become easy. Please revise Python stats. Whatever we have done in Python, revise that and statistical part as well. Please be up to date. If you'll be up to date, then you guys will be able to follow me. Yes. Next one, okay. Let me check, Kisan, what we have next. If EDA is there, I will tell EDA. Otherwise, let me just check it. Next we have pandas. So pandas numpy, yeah, we need to finish that as well. We'll do pandas numpy. Matplotlib will come after that. Pandas numpy will do cleaning, matplotlib, and then EDA. Yeah, before EDA itself, correct. Yes, Kajal, but please see, I am in very lower pace, Kajal. I cannot go lower than this. So please, I think you just need a revision, Kajal. If you'll revise it, then you should be able to go in hand with me, right? Why I was statistics you can do. Okay, for tomorrow I am doing pandas and all. Okay, do one thing, just revise Python part. Don't revise the stats as of now. So I reduced your homework. Revise Python. Whatever we have done in Python, revise it. Then we'll do NumPy, Pandas, Matplotlib, and Seaborn. The next thing will be that. Okay? Great. Any other issues or concerns with me? Please let me know. Any suggestions? Just okay, do one revision on that stats. Then go through the notebook, and if you have question, come to me, Praveen. Okay, Shamal. Thank you, Prakash. Thank you all. Please take care. Bye. Yes, Praveen. That's why, na. I was shifting new home, everything. It took me time. Okay. Bye. Thank you. Take care. See you tomorrow.